Hey everyone, we're going to start with problem 11a. So the instructions say to find the domain for each function and use interval notation. So looking at this function f of x, we see that we have x minus 3 over x plus 2.9 times the square root of x plus 6.4. So there are two main things we need to be looking out for. We can't divide by 0, and we can't take the square root of a negative number. So first, if we look at the denominator of the fraction, we see that we have x plus 2.9. So like I said, we can't divide by 0, so that means that x plus 2.9 can't equal 0. If we solve this for x, we'll get that x can't equal negative 2.9. Okay? Next, if we look under the square root, we have x plus 6.4. So I said earlier, we can't take the square root of a negative number, so we need this to be greater than 0. Greater than or equal to 0. In other words, positive, not negative. So if we solve this for x, we'll get that x must be greater than or equal to negative 6.4. So now we can make this in interval notation. So first, our lower bound is going to be negative 6.4, and we can go up to negative 2.9. Then we have a break in our interval here, so we need to use a union sign. We can start again at negative 2.9. We have no further restrictions, so we'll go all the way up to infinity. Next, let's move on to part B. So looking at this one, we can kind of look at the same things again. Let's look at our fractions. We just need to look at the denominators since there's no square roots here. So first, we need to know that 5x plus 4 squared can't equal 0. So now, to solve for x, we're going to take the square root of both sides, which gives us 5x plus 4 on the left. The square root of 0 is still 0. We'll move 4 over, so we'll get 5x can't equal negative 4. Then finally, x can't equal negative 4 over 5. So that's our first restriction. Next, we'll look at the denominator of the other fraction, which is x minus 3. Again, the denominator can't equal 0, so we'll solve for x, and we'll get x can't equal 3. Okay, let's build our interval again. The lowest possible value we can have is negative infinity, because unlike the previous problem, we don't have any greater than or less than restrictions. That negative infinity can go all the way up to negative 4 over 5. Then our interval stops. We start again at negative 4 over 5. We go up to 3. Stop again. And start again at 3. Go all the way to positive infinity. Okay? So the reason those breaks in the interval happen is because we have these specific x values that x can't be equal to. So we need to take those out of the interval. Okay, now let's look at problem 12. This problem says that the monthly charge for water depends on your usage. For a customer using no more than 20,000 gallons of water in a month, the monthly charge in dollars is given by the function c of x equals 0.004x plus 15, where x is the gallons of water used. What are the domain and range for this function? So first, let's look at the domain. So what is the minimum amount of water somebody could use? That answer is 0, because nobody can really use negative water, but there's might be the case where somebody doesn't use the water in their house for a month if they're away for a time or something. So first, the lower bound of the domain is 0. And you'll notice that in the problem, it says for a customer using no more than 20,000 gallons of water in a month. This places an upper bound on the domain of this function. So the upper bound is 20,000. Now moving on to the range, it's a little harder to figure out, but what we can do is if we know the smallest possible x value and the largest possible x value, we can just plug these into the function and that will give us our values for the range. So if we do that, we will get 15 for the lower bound and 95 for the upper bound. Okay. All right, next we're going to look at problem 13. Problem 13 says the graph of a function g with domain from -2 to 7 is shown. Find each of the following, use interval notation. So first, this problem asks for the increasing intervals. In other words, what intervals of x values is the function increasing? So if we're looking at this, we'll notice that first, the function increases from -2 to -1, and then it starts to decrease, but then it increases again from 4 to 7. Now looking at the decreasing intervals, it seems pretty obvious that the only option is what's left, but if we look at it, we can tell that it's decreasing from -1 to 4. Okay, now it asks about where the local maximum is and what that value is. So first, we have to know that local maximums don't consider the endpoints of the domain interval that we're given. So we see that the local maximum of 4.3 occurs at x equals -1, this point right here. And the rate of change at that local maximum, according to our definition for a local maximum, it should always be 0. Next, it asks about the local minimum. So again, we don't consider the endpoints, and the lowest y value in this interval is at 4 and is a value of -8.2 at x equals 4. Again, for the same reason as the local maximum, the rate of change at the local minimum should be 0. Now, moving on to the absolute maximum and absolute minimum, we will now consider the endpoints of the function. So now we look up here and we see, okay, that one's a lot higher than anything else. So our absolute maximum is 10.7 at x equals 7. And our absolute minimum, even though we're considering the endpoints, our point at 4, -8.2 is still our absolute minimum. Okay, now we will look at number 14. It says that the graph of a function g is shown. Assume the graph's end behavior continues as suggested and use interval notation. So part A says estimate the x interval or intervals on which g is increasing and concave up. You'll notice that it tells us that there's an inflection point right here. This is important. So first, we can tell that the graph starts increasing at x equals -2.7. But now we need to check if it is also concave up. And since we can see this little bowl shape going on in the graph at the time, then we should know that it is concave up. Here's that kind of bowl shape I'm talking about. Okay, and so this interval is going to be from -2.7 to -0.3. There's only one interval at which this happens. Next, we need to estimate the x intervals on which g is decreasing and concave up. Okay, we see that at the inflection point, if it's concave up to the left and it's concave down to the right, we need to only consider stuff to the left. So this is where the end behavior of the graph comes in. When we're looking at this, it seems that if we go all the way to x equals -infinity, it seems that that graph, as we increase x, is always decreasing. So to me, it seems that the graph decreases and is concave up from -infinity to negative 2.7, where it switches to increasing. Next, we'll look at estimating the x intervals on which g is increasing and concave down. We know that the graph switches to concave down at the inflection point, and it seems to still be increasing after that inflection point, all the way until 2. So this interval is going to be from negative 0.3 to 2. Okay. Finally, we'll estimate the x intervals on which g is decreasing and concave down. Like I said, the graph switches to decreasing at x equals 2, and it seems to continue that way for the rest of the graph as x approaches infinity. So this is the interval on which g is decreasing and concave down. Okay, next we're going to look at problem number 15. It says, what is a formula for the quadratic formula described in the table? Write your answer in standard form. So looking at this table, there's a few things that I always tend to look at. I look at where things are 0. So f of x is equal to 0 when x is equal to negative 5, and again when x is equal to 6. So we know that these are the two zeros of this function. So I'm going to say that our function looks something like this, where we have x plus 5 times x minus 6. And also, we should include this letter a. And we should do that because that a accounts for the stretch factor of this quadratic function. And so, but now, how do we figure out what that a is? So what I'm looking at now is that when x is equal to 0, f of x is equal to negative 15. So if I say that f of 0 equals a times 0 plus 5 times 0 minus 6, I will get that this is equal to, well, I know that this is equal to negative 15. I'm going to simplify what I have here, and I'll get that a times negative 30 equals negative 15. And if I move over that negative 30, I'll get that a equals 1 over 2. So this gives us our stretch factor. So now, to get this in standard form, I need to FOIL these two factors and incorporate my value for a. So I'm going to do that, and what I get in return is this. I'm going to distribute 1/2, and we'll get 1/2 x squared minus 1/2 x minus 15. And this is a possible formula for the quadratic function described in that table. Okay, now we're looking at problem 16. It says to find a formula for a quadratic function with vertex at negative 6, 1 and passing through the point negative 2, 8. Write your answer in vertex form. So in the last question, we had to write our answer in standard form, but here we're doing it in vertex. So vertex form is going to look something like this. It's going to be f of x equals a times x minus k squared plus h. And k is the x coordinate of the vertex, and h is the y coordinate of the vertex. And then a, again, like last problem, accounts for the stretch factor of this quadratic formula, and we'll have to figure this out later. Okay? So first, we're going to plug these values for the vertex in. So we'll get, this is equal to a times x minus negative 6 squared plus 1. Okay? Minus negative 6, that's just the same thing as x plus 6. Okay? So now we have this being equal to f of x. So I'm just going to write that Now we need to figure out what that a is equal to. And it gives us this other point here. And we haven't used that yet, so let's see if there's a way we can. What I'm going to do is I'm going to plug in this x value for x in this equation. So I'm going to say that f of negative 2 is equal to a times negative 2 plus 6 squared plus 1. And I know that this should be equal to 8 because of this point. So I'm going to keep going with this. This becomes a times 4 squared plus 1 equals 8. So 16a equals 7. I just squared that 4 and subtracted 1 from both sides. To solve for a, I'll divide both sides by 16. So a equals 7 over 16. Just to write our final answer in vertex form, we'll take that f of x is equal to 7 over 16 times x plus 6 squared plus 1.
Surprise, new tutor. So let's pick up back at number 17. Convert the quadratic function, this function, to vertex form by completing the square. Then identify vertex axis of symmetry and sketch a graph of the function. Uh-oh, completing the square. I know that's scary to a lot of people, but I promise you it's not that bad. So complete the square, what are we doing? Well, we're going to take this function right here, and we're going to try to find a perfect square, a little binomial that we can split it up into, and then tack something onto it just for fun. So how do we do that? Well, the first thing I notice is that this 3 is kind of in our way. Why? Well, perfect square binomial, right? It's going to have to be something like this. Squared, right? This means that we need something x squared, some number here that is going to give us 3x whenever we square it. We could pick square root of 3, but that might get ugly. So what we can actually do here is just go ahead and factor out the 3. I think that's good practice with completing the square. So let's go ahead and do that. I'm going to do it right here. So 3 leaves us with x squared minus 8x plus 43 over 3. There we go. We factored out the 3. Okay, now what? Well, now we got to find a way to take this thing right here and make it into that perfect square. So the first thing I notice is that let's write this out here. Let's find a way to do that. So first we know we're going to have x here, right? And it's going to be a squared term. So what does this number that's going to go next to x plus or minus x, what does that number have to be? Well, it's going to have to add to itself to get 8. So I mean, it has to be 4, right? Well, we can check that. So now let me just show you what I'm talking about by doing the multiplication out for this, right? This will give us x squared minus 8 plus 16, right? Oh, sweet, cool. Notice that this right here looks exactly like this right here at the beginning does. They look the same. Oh, I missed the x there. There we go. Okay, what about that plus 16? Well, let's write that in terms of thirds. Reason being is that it's going to match up with what we already have. 16 times 3. What is that? 48? Right? Okay, cool. So now we have it written like this. What do we have to do to this right here to make it this? This up here. Well, you might notice this one here has 48 thirds and the other one has 43 thirds. So all we got to do is take away 5 thirds, right? So then would you agree that if we have x squared minus 8x plus 48 thirds minus 5 thirds, well, this should equal, right, x squared minus 8x plus 43 thirds. Wait a minute, that's exactly what we have up here. Look at that, that's nuts. So, because this 8x squared minus 8x plus 48 thirds is equal to this little square term we have right here, all we got to do now is just, all we got to do now is just take away 5 thirds. And incredibly, we've completed the square at this moment. Okay, so what do we got to do now? Well, let's get it into vertex form. So this means we need to distribute this 3. That's not so bad though, right? Squared minus 5 thirds times 3, so minus 5. Okay, well, there we go. What is the vertex then? If you call vertex form, it's in this form. Y equals a x minus h plus k, where the vertex is hk. Okay, so what's h in our case? Remember, it's minus h, so it's minus 4. So that would be first thing of our vertex. Plus k, well, it's plus negative 5, right? Boom, 4, negative 5, that's our vertex. Axis of symmetry. Axis of symmetry should just be the x-coordinate of the vertex, if you recall. So, what's the x-coordinate of the vertex? Well, it's 4. So there's our axis of symmetry. Now let's sketch a giraffe. Sketch a giraffe. That would be fun if we sketched a giraffe, but I'm actually going to sketch a graph. Sorry. So, where's our vertex? At 4, negative 5. Well, let's say this here's 4, and this here's negative 5. Real nice and simple. Is this concave up or concave down? Well, there's a positive 3 in front, so it should be concave up, right? And I'm just going to make a little sketch here. Maybe first think about when x is 0, what does this equal? Well, it should equal 43, right? So maybe a point way up there. Oh. Okay, there's my cool sketch of this graph. Yep, there we go. Not bad, not too bad at all. Okay. On to number 18. An apple is thrown vertically into the air. Its height h in feet above the ground at time t in seconds is given by this function. Find t when h of t equals 0. Let's put the brakes on right there. Let's just start by doing that. That's not so bad, is it, right? So anyway, that means we just set h of t equal to 0, right? 16t squared plus 48t. Awesome. Well, there's a couple ways you could solve this, but first one that I notice is that you can factor this, right? There's a common factor. All these things, t goes into them, right? Each of these two things that we have. T goes into this and this. 16 also goes into both of them. So let's knock them both out and factor out a 16t. Then we will be left with negative t for that one on the left, right? Plus, I believe, 3, right? 3 times 16 is 48. All you at home with your calculators, triple check me. Yeah, and remember this all still equals 0. Now remember, a little property of when things equal 0 is that if you have two things that multiply to get 0, that means that one of them, if one of them is 0, everything's 0. So if this one in the blue is 0, or the one in the green is 0, so that's why we'll get two answers. What about the one in the blue? T equals what makes that 0? Well, it's 0, right? Because 16 times 0 equals 0. Let's do the one in green. So what does t equal to make the green one 0? Yes, you in the back. 3. How did you come up with that? Oh yes, very correct. The student in the back has told me that it's because if you put 3 in for t, negative 3 plus 3 equals 0. Yep. There we go. Hey, there we go. There's 0 2 times. So let's think about this. What is happening to the apple the first time h of t equals 0? There's a question here. Well, the first time is at t equals 0, right? That represents 0 time. And the height is also 0. So this means at 0 time, the height is 0. So I guess this means that the apple is thrown from the ground. So it starts at the ground, right? Then the apple probably does something like this, and then it falls back, right? And then it falls back at t equals 3. So that means what happens at the second time? Well, t equals 3, that means that the apple has flown up and fallen back down and hit the ground. So there you go, that one's not so bad. Let's look at part B, though. What is the maximum height that the apple reaches? At what time does it reach the maximum height? Well, the maximum height in our little sketch would be up here. What is our math word for that point? Yes, the vertex. Excellent. I'm so glad you're participating. Anyway, so let's go ahead and find the vertex. You might have learned in class that the x-coordinate of the vertex, right, is negative b over 2a. Well, in our equation, what is b? Well, that's 48, so let's go with negative 48 over 2a, so that should be negative 32. What does that equal? Well, that actually reduces to 3 over 2, or 1.5. So, okay, that's the x-coordinate of the vertex, or I guess t, right? So you could say it reaches the maximum height at t equals 3 over 2, so 1.5 seconds, right? Well, what is the maximum height? Well, we got to plug in that value for t there, right? Let's plug this back into our equation, and we'll find out. So let's go ahead and do it. So negative 16, 3 over 2 squared plus 48, 3 over 2. You can put that in your calculator, but that would be, what, negative 16 times 9 over 4. Why does the Apple Pencil keep doing that? Plus 48 over 2 is 24, times 3 is 72, so plus 72. Negative 16 over 4 is negative 4, times 9 is negative 36, plus 72, right? Again, feel free to check me. So 72 minus 36, let's see, that's 36. Okay, so that'd be the max height. There we go, we've done it. On to the next one. Okay, number 19. Suppose a quadratic function has the following properties. Zeros at x equals negative 2 and x equals 8, and vertex at 3, 12.5. What are the domain and range for this function? Well, whenever it gives you stuff like that on a silver platter, I think it's hard to refuse drawing a little graph. Or sketching a little graph, right? It doesn't have to be super exact. It's all right. So, zeros at x equals negative 2. Let's say this is negative 2. And x equals 8. Well, let's say this is 8. Vertex at 3, 12.5. Let's say this is 3. And this is 12.5. How about that? Okay, well, we can make our little sketch here. Obviously not, maybe not a Rembrandt you can hang in the National Gallery. However, gets the job done. So now that we have this visualization, let's think about first the domain. So question you got to ask yourself with the domain, are there any values of x that this function doesn't work for? Well, it's actually in the title. It's a quadratic function. Quadratic functions are polynomials, right? And polynomials, well, they're continuous. So our domain should actually be negative infinity to infinity. Now let's think about the range. What is the minimum y value that happens? Well, it keeps going down forever, right? So let's say negative infinity. What's the maximum y value? Well, it should be, right here at this vertex, right there. And what's the y value there? Well, it's 12.5. There we go, real simple. You might be wondering, well, what about the zeros? Well, in this example, they kind of just don't matter in this particular question. So maybe a bit of extra information. All right, for the next one, it says, write a formula for each situation. Heather planted 20 tomato plants in her garden in 2018 and has been decreasing the size of her tomato garden by 2 plants per year since then. Let P be the number of tomato plants and T be the number of years since 2018. So let's think about this. It says exponential functions, right? Does this sound exponential though? It really doesn't sound exponential to me. It's decreasing by a constant rate, right? It's decreasing by 2 plants per year every year. So this actually isn't exponential. This might be a little warm-up to the rest of the problems. So if it's not exponential and then there's a constant rate of change of 2 plants per year, right? Well, what kind of function is it? Must be linear. That's right. Everybody said it together. Wow. Anyway, 20 tomato plants. We start with 20, right? Think about our line. So that would kind of be like the y-intercept, right? If x is 0, or t is 0, sorry, time is 0, we start with 20 plants. So that would be our y-intercept. 2 per year are going down. Well, this means that every year, right, 2 are going down. So look at that. We wrote a linear relationship. This means that every t years, we will be decreasing by 2 plants, and we started 20. So awesome.